All right, let's get started. So, hello everyone. Welcome to today's webinar, which will be talking about real-time context engineering with CocoIndex and VeloDB. So first, I wanted to quickly introduce all of our speakers and panelists for today, starting with Ling Hua, who is the CEO and co-founder of CocoIndex. Myself, I'm Kevin, the principal product manager for VeloDB. And then today we have Tom, one of our solution architects, who's also going to take us through a live coding exercise. Really quick view for the agenda. First, we're going to introduce and provide a little bit background about VeloDB and CocoIndex for those who are new to the community and and for the companies. We'll really then spend some time going through the challenges of real-time context engineering, as well as what does that really mean in our context, like the problems that we're dealing with, as well as the challenges that are preventing these problems from resolved up until now. Then we're going to share our solution with CocoIndex and VeloDB on how to actually solve some of these challenges, followed by a live coding demo of this in action. And then we'll have some time at the end for questions. So if you're curious about how this could be applying to your projects or your organizations, we can take that time to discuss. Uh, First, I'll go through some introductions for VeloDB. So we're a real-time analytical and search database. So really providing the ability to do your online analytical processing in real time, as well as all of the search and retrieval capabilities that are typical with like log analysis, and then now extending into AI for providing knowledge and context so that LLMs can make the right decision. The company is founded in 2022 by the original creators of Apache Doors. This is the open source project that's behind the company. And we're headquartered in Singapore and the US. So if you'd like to learn a little bit more about the company, happy to discuss or just check out our website. Now, onto the technology that's behind the company, which is Apache Doors. So this is a Apache top-level project that came out of Baidu out of the necessity for serving real-time analytics for ad targeting. Since that time, the project has grown to cover more use cases, starting with observability and search, where major investments were made, and then following all of the recent workload trends, taking on hybrid search, vector search, but always with a root in real time and performance. It's a quite vibrant project with almost 15K stars, as well as over 5,000 enterprise users. And you can see some of the logo here on the adoptions by some of the biggest companies in the world, across the world as well. As to what exactly, where in the ecosystem VeloDB plays in the data management stacks, just wanted to provide a quick overview so you can see how it plays. Because it's a real-time analytics processing, it gets data from operational sources. These sources could be transactional databases such as MySQL, Postgres, where data are change data captured over, replicated over, or it could be coming from streaming sources. And we're compatible with Kafka, Red Panda, and most major streaming uh, tools. And as is a database for analytics, there are some pretty traditional use cases that are used that people use VeloDB for, such as BI and visualization. So think about your traditional kind of BI reporting for analysts, understanding product trends, making decisions, but also for observability, where you can use it for log analysis because of the search capabilities. You can do full log search as well as joining that data, that the result sets, with relevant metrics that you care about. So very powerful in that warehousing and generative AI. But also for real time, the needs really extends to customer facing in the sense that if you have somebody that is trying to ask a question on your platform, this person probably can't really wait that long, as there's only a certain amount of time, patience that person has. And now in the AI era with agents, these response time has to be fast as well. So with those particular needs, we also offer extremely low latency queries, fast ingest, and high concurrency to meet those needs. And then, of course, now with generative AI, putting it all together when we're combining all of these different search and retrieval methods to provide a cost-effective and accurate solutions for knowledge store and context engineering. And that is the focus for today. I'm not going to go into too much details about the internals of VeloDB, but just to give you a brief overview of the technology. So as we get into the more technical side of the conversations, it hopefully will help um, with the flow of things. So VeloDB follows a lakehouse architecture with full compute and storage separations. It can work with external open table formats as well as having its own internal formats for that real-time capabilities. Like most modern databases, that are widely distributed, we follow an MPP architecture with a cost-based optimizer, pipeline execution for concurrencies, and a full vectorized engines to take advantage of modern CPUs. So you really get the best architectures and the best optimizations from modern database platforms with the ability to extend this to democratize access for all of the other datas in data lakes or other sources such as other databases. So you can see the streaming catalog integrations as well as the storage and file integrations in this diagram, as well as some of the key technologies. If you're curious about other use cases other than the knowledge source and context engineering, we'll have some time at the end to explore those as well. Now that I spent a little bit of time about VeloDB, I want to hand this over to Linghua to give a brief overview of CocoIndex before we dive into the conversation for today.
Hello, friends. Yeah, I think I'm Lin Hua. I'm founder of co-founder of CocoIndex. So what does CocoIndex do is it is a persistent state-driven data transformation framework. What does it do? It takes the data source from unstructured data, database, web, that are dynamically changing. Then you declare transformation with Python. That is not a DSL hosted language. And then you can transform it into like vector database, search analytics like VeloDB is our great friend. And then the thing about the Coco Index is the world is dynamically changing. So when your data is changed, your code is changed, it will only does incremental updates or processing to what has changed. And you can use it to do like real-time code-based indexing, Notion, meeting notes. You can use to build knowledge graph for meeting notes. You can use it to track the change of a website and build some like trending topic detectors and stuff like that.
Yeah, awesome. So hopefully this gives a brief overview, but let's dive into the problems next.
Yeah, I think in general, the challenges with context engineering in 2022 is about agents going to production. The reason why Coco Index and VeloDB is a great combo is first, reliable agents needs reliable context that is fresh. So if you're building like a code review agents or coding agents on top of a big corpus and is always changed, you want to save developers time. So you want to bring in the right context to the AI to reason over. So reliable agents, fresh context, that's like 0 to 1 problem. The second problem is there's gonna be constant re attention between resource and a trade-off between resource and data freshness. So if you run it on the edge, you may have limited compute. If you run a cloud over a large, massive data set, you still have the same similar problem. And then in the end, it's also about like explainable AI. How do we help users to understand the lineage so it is properly governed to your data and AI stack? Yeah, for example, do you know like how AI is transforming the data when you vibe code it with like a list of data transformations? Do you know what it is doing to your data? So all of these are great and observability too. So all of these are like very, very important in the stack.
Yeah. And just to dive in a little bit more with maybe some example on where some of these challenges are surfacing, like with all of these, we really need to look at the end-to-end workflow because we can say that this is an ingestion problem, or it's a retrieval problem, or it's a data problem, or it's a routing problem. But for real-time context engineering to really be able to serve this fresh context in the right application, we need to look at all of the steps in that workflow, right? So with reliable agents with fresh context, one of the examples I wanted to kind of bring up is this coding agent. Imagine if you have multiple sets of people that are working on this code base and they're all merging code at the same time and there's dependencies dependencies in between, it could get very, very complicated to make sure that the right context from one dependency chain is propagated to the others in the short time frame. Otherwise, you're going to see collisions and other things. This also extends to things that are sensitive. Like if you have an AI that's making any decision that is time sensitive, then you really, really need the most recent context, or else there's going to be drift. Now, with resource and freshness trade-off, I would be lying if I say if you throw enough money at the problem or throw enough resources at the problem, you probably can solve it. But then we get into the ROI situation. For example, if one part of a document changed, do you re-index and re-embed the entire corpus, which is both a compute problem on the indexing side as well as on the ingestion side? Or is there a better way of doing so, in which case you may, update it in batch, you may do it once a day instead of once an hour or once every half an hour, but now you have the freshness trade-off. And this trade-off is every single step of the way. It's the actions from actually defining the structures and the metadata, as well as the actual movement of the data itself. And lastly, as Linghua said, we all want to understand what our agents have done and how and what are the data and context that impacted those decisions. So having the ability to understand is going to be critical, especially for production use. Anything else to add here, Linghua?
Yeah, you explained really well. So we can maybe
Well, yeah. So now that we understand the challenges and the spaces and the things that we're going to look at, I'm going to hand over to Tom to talk about the solution that we have created with CocoIndex and VeloDB.
Uh, so Kevin has introduced a lot of the general topics about what kind of the challenges we have for the context engineering. And now I will go through how can CocoIndex plus VeloDB can merge together to resolve the context engineering problems. The context engineering problems, the challenges come from the things like comparing to previous things, we need to feed some sort of the content to AI and make AI agents to take their actions. In that way, the content itself is hard to manage because it is unlike other data we said before, like some sort of the data in the schema in the table. It is highly diverse and is highly unstructured. For example, your code bases, your slides, your voices, or anything you have that is unstructured, and you need to have some way to manage those things and to ingest those things into some sort of databases and to do the retrieval. And in such a kind of pipeline is some sort of general practices for context engineering. And in here, so you can consider to choose the CocoIndex plus VeloDB to help you to handle both kind of situation. Firstly, consider about the CocoIndex. You can think CocoIndex as something you can incrementally process your data and to put those data to synchronize the data into your target data sources. For example, you have some sort of changes in your code, some changes in your databases, or some changes in anything in your content. You do not want this content to get lost by the agent if they want to catch up in time. So the CocoIndex can do is that they can do the incremental processing for any kind of the changes in your code bases or in your data sources. And then it will do the incremental update to the VeloDB side and to store and to update the relevant things like the row context, the row chunk, and the row vector. And once the data get updated, the VeloDB can do real-time, really high concurrency, hybrid search, and can do a real-time sub-second refreshness to help your agent to retrieve the right and accurate data. Okay, taking an example to how the context engineering work for the coding agents. For every kind of coding agent, you may have experiences. You may use Cloud Code, you may use Gemini, you may use Codex. Every kind of coding agent is working by some sort of the way, like you input a single problem, that is your user prompt, and it will fulfill the context by doing their on searches. They will search by their tool uses, like to search by grep search by GQ or search by any kind of way to find the most relevant thing. And then based on the context they have been grabbed, it will make some sort of code changes and maybe if your program is okay, they can do the test. And in such a way, there's definitely something that can be resolved in the most efficiency thing is for the code search part because for the coding agent for the up-to-date situation is that they can only understand some sort of the keyword or some sort of the information that is definitely showing the code. For example, you search for something like authentication. They can find some sort of a similar word to authentication and do the grab. And that will be some sort of the problems is like, for example, if you have a lot of the codes which area code has covered with the authentication, the context itself will be blocked. So and that is the reason why you want to use something to help you to get some sort of better information to help you reduce the token and also to help the agent to do the right decision based on the fewer and the more meaningful information. So for here is a typical pipeline to understand what kind of the typical things we can help with the content engineering for code. For example, for any kind of code bases you have, we can firstly scan for the files which is in your programming language, that is Python, Go, Rust, and then it will use trace and it will get ingested into CocoIndex by using the tree setter to set up to understand the AST and to do the chunking. And after that, it will and CocoIndex can also help to analyze your code bases to understand what kind of file type it is and understand what kind of the function name, what kind of methodology to use, and to extract the import and course. And lastly, CocoIndex itself can do the transformation to help to transform the chunks into embeddings. For example, for this demo, we use some simple lightweighted mini language model L6 for the embedding and can chunk the AST chunk into embedding vectors. And once they do those transformation, all the data will be uploaded into stories for real batching way and to help the people to do the analytics based on the keyword, based on the vector, or based on the variance or based on something else's. So for the ingestion layer, I have introduced that the context from the raw context, which is the code bases, and to the final target, it needs to do the transformations. The problem for the transformations, like if your coding agent continues to grow, for example, for every session there will be a lot of the code changes, and your ingestion pipeline, if they cannot keep up the speed, the final product for the retrieval will be hampered as well. For example, if you update the key logic, but you have still retrieved the wrong logic, the AI agent will definitely know that that will stay in the old logic and cannot go away. That is one of the key issues happen for the programming task, like some sort of a drift. For example, if you do the coding agent and do some sort of the task which is long running, and you keep prompting on something that is irrelevant to the single problem, the agent will gradually forget what they have done before, and they need to retrieve again. And maybe if they did not retrieve, they will have illusion, which is a key problem that will be resolved in the ingestion and for the processing there. And that is a thing like how CocoIndex can help you to resolve those things. They do file changes in a really efficient way because they can do those things by incremental processing, which means that they can track on the files for the files checksum. They can track on the single function level checksum. They can also check on some sort of the git commit. So if anything changes for the checksum or commit number, it will be only reprocess those changed files. And maybe the first one is slow, but for the second or for the further incremental changes, the speed of the transformation and for the ingestion can be ultra fast, which will be suited for the AI agent or for the coding agent part as well. Also for the retrieval parts, So because everybody knows that for retrieve they might need some sort of the semantic search. But why we need to substitute some sort of semantic search? The primary reason is like keyword search does not always cover for the semantic meanings. For example, you search for one word like the JWT token. How does those things work? Maybe they do not have say that they do not mention anything related to the keyword in the JWT. And they need to understand those things that is the authentication problem and to find the code block logic which is related to the JWT or to the logic part. And the way computers or for general practice can do is like you can put your queries into a vector using some sort of the embedding models. And those embedding models can be used to convert your query into some sort of high dimensional vector array. Like for the demo, it uses media LM and it has around 334 dimensional vector array. And it can match with the code bases to find the most relevant array based on the cosine similarity comparing to the code box. You have a cocoa that has been processed or has been transformed into the code bases. That is how semantic search works in the code base related retrieval. And also for the keyword search, the keyword search can be understand that it is not just related to grep, it is also related to the scoring because for algorithm part, there's a lot of way to identify whether one keyword is important or not in a chunk or in a documentation. And that is done by some sort of algorithm by using some global statistics like the BM25 scoring to judge whether the keyword is important or not by some sort of score. And if you search something, and that in that way you can rank your keywords into some manners that is helpful for you for you to judge whether the keyword is matters in this file or it's just some sort of comment or an annotation which appear everywhere. And that can help you to gradually increase the precision for the keyword part. And the third part, I think that is also important in the in the code agent to understand your code is to understand how your code work together, like how the test import your code and how the code get inherited and how to get a call or get importers for given functions. And in such way, they need to understand those things into some sort of the graph things and they need to understand how the functions get interconnected with each other and how those things can get some sort of a traversal to understand what kind of the function logic get called. That is the key logic that people needed to understand the basically everything for the coding agent and to do the context engineering. I will do a quick demo to share my screen and to show how things can work together with the CocoIndex code and for the Doris part. So for the live demo part, I will go through the code base, which is a very popular code base, which is OpenClaw. OpenClaw, maybe everybody know about that, but I can do some quick introduction. For the OpenClaw, it is some sort of a library that can help you to install an agent in your phone, in your Mac Mini, or in some sort of the Docker in anywhere you want, and it will just do something autonomously. Like it can connect with your Telegram, connect with your WhatsApp, connect with your Slack, and to automatically handle your instructions and to do the relevant coding agent relevant operations. But the challenge for the OpenClaw is like the code base is really big. It has a lot of the different language. Like they have Kotlin to handle with Android related logics. They have the Swift to handle with iOS or handle with MacBook related logic. And it also has Python to serve as a glue language to handle the rest of the logic and also have TypeScript, which is used to have some other things. And the total size of the code base is around 5,000 files and more than 400K number of codes. So what CocoIndex can do, like So in here, I will use a library named the CocoIndex code, which can help us to analyze the code bases using CocoIndex to do the indexings. What it can do is like it can wrap the codes into some sort of to process those things into the chunk and to get those things and to store those things, export those things into the stories. The first thing is for the indexing. So during the indexing, it will separate the files into the chunks, and it will also be able to handle and also be transform the chunk into vector and to store those things into the Doris code base. So I can run it. So if you want to index a code base, the command is looks like here. So you can see if I have ingested those things before because it has really long files and it may need like 5 minutes or 10 minutes to get everything to be ingested. So I have injected this in previously. And we can see like for the file number is around more than 5,000 files. And we have the TypeScript, we have Markdown, we have JavaScript, Go or Python, and that is all relevant to the and that is all get relevant together into the code base. And if we want to find something which is meaningful in semantic way, we can do is like we can query via the vector search. Like how does the message how does the message routing work? It will first load the model and to get and they can get the vector-based similarities based on what kind of thing they have done. For example, in here, you want to understand how does the message routing work. It will do the vector searches and to find the most relevant markdown, which is related to documentation, and also to find the most relevant code for how does the message routing to get finished by some sort of the key logics in here. Also, and if you want to just search for some sort of keywords, like to search for the send messages, and you can see that they can fetch for the exact matching for a given method who has a send message in their in their function body or in their definitions. Like in here, you can see that is a send message, and that is some sort of the relevant information or get stored and maybe get truncated. And also you can combine those things together to get some sort of a result which is in a hybrid search way. For example, in here, you do the hybrid search on the Telegram channel handler using hybrid search. And it can get some sort of the score by combining both the vector and the keyword together. You can the hybrid search they do is like you can get any kind of a score to judge whether the vector matter more or the keyword matter more, and to give you a better result. For example, in here, you search for Telegram channel handler. It will get you the markdown informations related to how the Telegram channel work and how the webhook work, and understand the code bases and relevant Telegram related types or some sort of a semantic meaning related GitHub issues or some sort of a Telegram related message boxes. By comparing those things together, we can see something that is get more directly. You can see there's a compare command. Like we can compare how does the vector, how does the keyword, and how does the hybrid search behave differently. So for the BM25, they have the score that is different, and for the vector, it has another score. And for the RF, it can combine the score together to get the score which combine the result of the BM25 and for the vector. You can see in here the origin, the channel routing. In this file, it is the chunk was stored like rented as the five number in the vector part, and after the hybrid search get done, get promoted into the first levels in the in as a chunk, and for the second part, it is like it is also ranked at the five position of the keyword search. And after the hybrid mechanism for the RF fusion, the thing will get ranked into the second in the hybrid search. For the third one, this is the templating TypeScript. It was ranked at the top in the vector, but it looks like it is not truly relevant to the message routing, and it will be decreased to a third level, and so do the rest two of them. And it can be something like more broader, like you can do the graph related searches. To those things, you can just search for something like the graph based thing. For example, in here you search those things based on the graph. So how does the graph get handled? Basically, for every chunk, they will have two siblings. So one siblings, they are callers who use that function, and one is importers what kind of a function get imported by the function. And by using those things, they can form a DAG which can combine how does the functions work together to how does those things get related to each other to help your language model to understand the coding logic in a more inspired and in a more intuitive way. For example, do the graph searches, it will get a score based on the two hop related relationships and to find the result as well. You can see like in the graph, they can find the different kind of elements and it can find the relationships and that is the neighborhood related informations. So you can see like it found something related to the normalized message channel, and that thing is not founded by the hybrid search or founded by the vector as well. Okay, and after introduced how those retrievals work and now I can show how can those retrieval help to build the context which the language model can be used to present to serve for their knowledge work on how to help them to do the coding jobs or how to help them to understand code bases and fulfill the documentation. It is the quick demo is showing like how those things can get together to get the final context we can deliver to our target language model. Example here. The runtime may look big, but it only contains around 3,000 tokens. Generally, if you do a coding agent scanning job, it will take at least 10,000 tokens or 100,000 tokens. And in such way, can think those kind of more cost efficient way that can generally help you to save around 70% of the the token consumption by using some sort of the advanced retrieval mechanisms. For example, here you search for the message routing, and in the message routing, it can help you find the most relevant chunk, which is located in which file and what kind of the thing it is, and what kind of the code snippet they have. And those things are ranked by the hybrid search and can get the scores. And in here they can have it can also can understand something related to the logic part, like how does those retrieve the contexts or how does those things get linked with each other. Like they can get the one hop operations to have the relationship between the templating and the functions how do they work together? That is the graph neighbors. Like in here is the one hop graph neighbors, and in here the one hop graph neighbor two, which is judged by the relationship between the retrieved messages and for the and their relationships. Uh, also, also, if you're wondering how you can understand those things using query, you can use the show query command that is in here. For example, in here, if you want to search for the queries using Doris, we can do the qhop related query using the CTE. For example, in here, we can get some sort of file paths, languages, and for the given kind of the import calls by using the JSON searches, and to get the one hop related relationships based on the caller and the importers. And then it can form the edges for different kind of the for the importer and for the callers using a one hop edge. And then it can be expanded to two hop. I think the two hop is the most relevant information and can help people to save the tokens, because if you have the chunk and you have like more than two hop, it may consume like potential large number of the tokens, which may not compensate for the token waste we have.
So I'm giving permissions to folks so now you should be able to come off mute and ask any questions.
I'll go.
So,
I'll go.
okay, go
This
ahead. Hi.
so a lot of this is over my head, right? I'm definitely in the vibe coding thing. Not I. I'm using AI to help me build things.
Mm-hmm.
Essentially, you guys, are you more of like a database? What would I use you over Supabase or some other options?
Yeah, so a great question. So there's two pieces here. VeloDB is a database. So this is where you would actually store the information. So whether that's the raw data, text data, tabular data, etc., as well as all the indexes. So a vector index, inverted index, PM25, etc. So it basically helps you to retrieve the context. So imagine if you have all of this information, you need to combine it with your prompt to an LLM. VeloDB handles the retrieval. VeloDB is also a real-time database so that you can write data very quickly. And then you can query it very quickly. So in a traditional database, depends on what you're using. It could be anywhere from multiple seconds to sometimes even minutes to run these queries if you're running a very large data lake. With VeloDB, we're looking at 1 to 3 seconds from when the data is created, ingested, and then served. That way, it allows you to have that real-time capabilities for structured, semi-structured, and also for the contextual data. But that's only half the problem, because for things to be real time, you actually have to get the changes into the database and understand exactly what changed and do it in a way that's cost efficient. And that's where CocoIndex comes in. So CocoIndex, unlike where a lot of the reindexing, reembedding, and re-ranking done today, which is all batched. So if one line in a file changes, you have to reindex and reembed the whole thing, which is very costly and takes time. CocoIndex does it in a stateful manner so that if only one line changes, then we only deal with the delta. Very similarly, if you're familiar with Iceberg, right? Iceberg is pen only, allows you to kind of just add the changes, allows you to write quickly and reconcile to the catalog. It's a very similar concept as that. Linghua, I don't know if there's anything else you wanted to add, but that's where I see the value. It's really to handle that real-time situation in a manner that's actually possible for production.
Yeah, I think in general depends on what your app is. If you're building like basically Postgres is like sorry, the Supabase is like Postgres, right? So I think in general you can also use Postgres for like I don't know if they have PG. Do you know if they have the PG vector on the Postgres?
I'm
Yeah,
not
yeah, they
understanding.
have.
I see. So I think in general Postgres is all more on the TP side. So if you're building applications sent with data on it, I think that's a good choice. So VeloDB in general, I think it's on, Tom, please correct me if I'm wrong, it's on the AP side. So it's search and analytics. So if you have like a lot of data, you want to aggregate, you want to build some analytics and search on top of it, then VeloDB may be a better option.
And just another note on Postgres. Although Postgres is a lot of time used for transactionals, there's a lot of modular plugins, so it allows you to experiment with a lot of things. So if you want a prototype, Postgres is great because you can try out a lot of things with a single database. So pgvector is a plugin. It has full text search. That's all these things. The problem is when you're trying to go into production at scale, when you need to handle high concurrency, when you need SLAs on the retrieval performances or the scale side of things, operationally it gets a lot more complicated. For example, if you have a large data set, you need to shard your Postgres. Now you have a lot of other problems because when you shard the Postgres, there's different statistics with each different segments. Your accuracy starts to drift, depends on who's looking at the data, or you're just not able to hit the SLAs to actually be for your particular needs. So that's kind of how I view it. Really great place to figure out what you want to do, but when you go into production, there are other considerations that you have to take as well. Tabitha, does that answer your question? I see there's a few other hands up. Just want to give time. Yeah.
I think it gets me started.
Mm.
I mean, again, I feel like a kindergartner listening to you guys, so try to figure it out.
Yeah, and we'll try to make it use as much of the plain language as possible, but it is really it's a really cool concept, and I think with all of the coding agents that are coming about, I think more and more people will actually really be able to get their hands on things as well. Cool. Yugesh, I see your hands up. Do you want to come off mute and share your questions?
I have, sorry, my voice is low, not being well. If it's not clear, let me know.
You good?
I have a few questions. A quick one. Is it possible to use Doris, install it on a Spark DGX? Or do you think that should attempt like a VeloDB? Do you have a free subscription, trial subscription for a little bit? That's the first question.
Yeah, so we do have so Apache Doris is open source, so you can always download it and install it. You can probably install it on your laptop if you want. So I'm not sure the exact hardware you're referencing, but it's totally possible to do this from using the open source. Now that also involves getting Docker containers, downloading the repos, doing all the setups. So if you don't want to deal with that, VeloDB Cloud is the easiest way to get to it.
Okay, is there like a start? I will look up online, like something easy to get started with. So there's something about
we have it's a one click to get into the environment, and then there's actually a lot of tutorials to help you get started. Those tutorials basically just set up all the SQL queries so that you can helps you with the data loads for some sample data, so you can really start playing with it.
Okay, I can get into my AWS environment also, I guess, easily then.
Yes, we have an option for bringing your own cloud. So in that sense, you can bring your own compute with.
So coming back to my original question, though, I would like to try Spark first because I'm trying to build my own coding agent using Quen system, experimental system. So as I do that, I would like to have also this on the DGX Spark. It's basically a Blackwell computer, personal computer, really.
Okay. So yeah, you can try to install this on your own.
Try to do that. Okay. Okay, cool. Yeah, well, thanks. I've been thinking about trying CocoIndex and this for a long time, but finally this weekend I'll get started with it.
Great to hear.
Yeah, we'll have more questions after that. Thanks.
Yeah, welcome. We welcome all those questions. You know where to find us. We have community channels. So on Slack, on GitHub, or on Discord. So yeah, hit us up. Well, if there's no other questions, I want to thank everybody again for taking the time to participate in this webinar. Hopefully you guys find value and also helps to, advance your own projects or your missions for your organization. And if you ever have questions or want to learn more, feel free to screenshot this page and we'll be there if you have any questions.
Thanks a lot. It's a great presentation. Nice work.
Thank you. All right. Have a great rest of the day, everybody.
Bye.